foundation and tray. Foundation and tray. Now, let me label this. Labeling also very important. So one of you please tell me what is this? This is called as tool post. This is called as tool post. And this is called as tail stock. It is called as tail stock. And all miniature components you need to explain them. Very important components only we try to explain. And this the tool post which will be carrying the tool. The tool post, correct? No, tool post which will be carrying the tool. The tool post and cross slides, all these will be onto other one component which is called as carriage. It is called as carriage, and this is called as a tray. In this tray we can able to keep the tools, and even the lubricating oil also will be flowing. And this is called as, what is this? This is called chuck. And this is called as this one. It is called as simply here the power drive systems will be there, and this will be called as headstock. Headstock. Okay. These are the important component, and even if you want, you can write this is a screw. You can call it as a screw. So these are the main important components of the lathe. So one by one, I'll try to explain them. I think you can able to write this. I have not used the scale to write it. You can use a scale and write it. Okay, if it's for 5 marks, or 5 marks it will not be given. It will be given for the 8 marks. If you write the neat figure, write the label the parts, write one sentence, you get 8 marks. Very simple. Now, the headstock consists of power drive systems in this. There will be motor, gears, gearbox, all this will be situated into this. So it is a source from our prime source. From this, the power will be given, so that it is called as headstock. And from the headstock, we have been extended pipe, and at the end of this pipe, we have been fixed a chuck. And there will be different type of chucks will be there. 3-jar chuck, self-centering chuck, 4-jar chuck. So many chucks are there. Here we have discussed about only a self-centering 3-jar chuck. The main purpose of using the chuck is to hold the job, which will hold the job. Okay, if you use the key, Allen key, and tight it, what happens? All the 3 jars will be opened, all the 3 jars will be closed. Already I have seen. So by using the key, we can operate the chuck to hold the job. All these I am telling you, you try to remember so that you can able to explain them in your own words. The chuck is one, it is a 3-jar self-centering chuck. In this, we are going to fix the cylindrical job or cylindrical workpiece. Okay. And let me come to the tailstock. See, if the job is slender in nature, the slender in the sense, see, if it is fixed like this, there is not much more extension, and it's not acting like cantilever peak. So that time we can directly do the work. If more of the workpiece is extended outside and going to do the machine operation, there is a possibility that it will bend due to its slender nature. So that to support the other end of the job or workpiece, you are going to use the tailstock. And in this tailstock, there will be one center cord. It is called as a dead center. Please don't write only dead. Okay, dead center it is called. Dead center is one. It is not having power, but it will be rotated along with the workpiece. Okay, the dead center will be there in the tailstock, which will be supporting the other end of the workpiece. Once when the workpiece length is more, and there is a possibility that it will buckle, it will bend. So to avoid this buckling, we are going to use the dead center. Okay, which will be supporting other end of the workpiece. Now let me come to the tool post. The tool post is one. In this, we are going to fix the tool. We are going to fix the tool. Okay, it is like this. we are going to open and we are going to fix the tool in this. Very simple. And below this, there will be two cross guides. One will be along the length of the workpiece, perpendicular to the workpiece. You have seen that. Please try to get into the mind what you have seen. Two cross guides will be there. If the lathe is like this, one cross will be like this, one cross will be like this. Okay? And our vertical movement is not there. Only the horizontal 2x and y direction it can move. So here these two cross guides along with the tool post all will be maintained on a carrier. It is called as carriage. The carriage is one which will be carrying the tool post and which will be carrying the carriage. Correct? Please remember this. Otherwise, they will not be having anything to explain or write. Correct? The carriage. So we have understood the check and the headstock, tailstock, dead center, and the bed, and the tray, and the foundation, and the carriage, and the tool post. These are the important components of the lathe. Any lathe if you took, these will become very, very important. Okay. Now after this, let me have a small discussion about before I get into the other thing. Okay. We'll try to have a small discussion about the specification of lathe. Specification of lathe is also important for you. Whatever it is not important, I'm not going to discuss here. The specification of lathe. See, once you have to order, or technically you want to describe the machine component. Some important configurations you have to say that will be a representative of the whole machine. Okay, that will be called as a specification. I want to place an order from here. I want to place an order to Germany after lathe. So I cannot describe it by words. I have to give this. These are the accommodations or things which I require in this lathe. They will be given the suitable lathe to you. Now, to specify the lathe, the important the things what we have to consider here. One thing, the distance between the dead center and live center. Distance between dead center and live center. Live center or headstock. That means to show it will be giving you what is the length of maximum length of which can be accommodated in the lathe. Correct? No? If the distance between the dead center and live center is given to you, it means to say indirectly, I can able to decide what is the length of workpiece we can able to hold in this one. The next one, what is the swinging diameter? Swinging diameter. The swinging diameter in the sense if it is rotating, I am going to open the check maximum, and if it is rotating, what will be the diameter, maximum diameter of the workpiece which can be held in the check? Not in the check, it can be held between the dead above the between the gap and the workpiece. It will be decided how much the maximum diameter of the workpiece which can be accommodated in the lathe. Correct? And the number of gear drives. Drive system. Drive system. That means how many types of gearings are available with the lathe. How many types of gearings are available with the lathe. And next one, the distance between the center to the bed. Distance between the axis of lathe and the bed. The distance between the axis of lathe and bed, this is one. Please look here. This distance. Okay. This distance, the center to the bed. this gap we are going to describe by this way. The center to the bed distance, how much it is. Okay, these are the things. Next one. Okay, these are very important things. These are very, very important things. And the next one, the power of motor, all these can be written, all these. Okay, power of motor, the power of motor. What is the kilowatts of motor? Whether it is 10 kilowatts, 20 kilowatts, whatever it is. Okay, so that will be deciding the strength of the plate. So these are 5 important specifications which essentially we need to remember. Okay, and apart from this, many other may be there, thus we can discuss them later. Okay, this is one. Next, what all the operations can be performed on the lathe? What are the operations which you can able to perform on the lathe? On any lathe, these are the operations we can perform. And I am going to finish this surface. What is this called? Facing. Very good. So please try to remember these words. Facing. Second one, I want to finish this. Some diameter I want to reduce. It will be called as a turning, plane turning. Plane turning. I want to do maintain 2-3 different steps. Diameter 10 mm, 20 mm, 30 mm, 40 mm. That will be called as step turning. Step turning. The next one, I want to maintain some the difference in the diameter. You can see that this is having some taper. Right now, so one side it will be maximum, other side it will be minimum. That will be called as a tapering. Tapering operation. And under this tapering operation, we have many other types. We can see them later. The next one, I want to do a hole in this. How the hole can be done? By using the drill. So this is called as a drilling operation. Drilling operation. Or the next one, I want to do a thread cutting, threading, internal threading I want to do. Okay, I want to do the external threading. So this is called a threading operation. And the next one, I want to create small grip on the surface. That is called as knurling operation. Knurling operation. You are understanding? And apart from this, key slot operation, grinding operations, okay, and the chamfering operation and creating the radius. Okay, so many other operations are there. All these are not required. Only we try to remember these: facing operation, plane turning operation, step turning operation, tapering operation, knurling operation, and the threading operation, drilling operation. These we try to remember. And if you list them, more than 200 different operations will come. All these are not important for okay to discuss. Now, basically, what we can do apart from the drilling operation, by leaving the drilling operation, almost all the first important paragraph which I am going to tell you that you have to text. The workpiece is held in a check. The other end of the workpiece is supported by a dead center. A suitable tool will be fixed in the tool post. The check will be rotated at required speed. What required speed? I don't want to explain it. Okay, it is a threading operation. I want to do a reaming operation. I want to do a finishing operation of the plane turning. The speed will be different. Speed will be different. Depth of thread will be different. Okay, all these are not to discuss. Workpiece will be taken. It will be held in the check. Firmly. Other end of the workpiece will be held in the dead center. Okay, and the required tool will be fixed in the tool post, and the check is rotated as required speed. That's all. This is the common thing you have to write. And if you put on to the explain later, no problem. This is the basic thing which you have to explain. Okay, this is one. And if you want, please write this one word. A common word where all the okay everywhere in bracket, please write it. In bracket, it is not for turning, planing, and objects. That's a simple word you have to remember. The workpiece is held in the check firmly. Workpiece is, or a job or workpiece is held in the check firmly. Okay. Other end of the workpiece is supported by dead center. Other end of the workpiece is supported by dead center. Fine. Other end of the workpiece is supported by dead center. Okay, there will be a dead center and the headstock, and headstock, the check will be there. Then the check we are going to fix the workpiece. And other end, the free end of the workpiece will be supported by a dead center. The dead center is in the dead stock, the tail stock. Correct, no? Tail stock will be there. And the next, a suitable tool. Here I am going to say the suitable tool because the boring operation, different tool will be there. Threading operation, different tool will be selected. And plane turning, it will be selected, different tool. So different tools will be selected for different operations. So a suitable tool, I am saying. A suitable tool is fixed into the tool post. Suitable tool is fixed in the tool post. The check is rotated at required speed. The check is rotated at required speed. Okay, this is the common thing. The check is rotated at required speed. What required speed? If it is a threading operation, for that